between the midpoints of a triangle. So a midsegment is a segment that connects the midpoints. You guys all remember what midpoints are, right?
The point in the middle.
The point in the middle. And we know that they're midpoints when they have dashes. So like D is a midpoint of BA because we got these lines. And E is a midpoint of BC because these lines tell me it is. Okay? So here, a midsegment is the line DE because it connects those two midpoints. So far, so good?
Yep.
Okay, the fancy thing about midpoints is that the midsegment is parallel to the third side. And it is also half as long. So obviously DE intersects two sides of my triangles, so those aren't the two it's parallel to. The one it is parallel to is AC. So we can throw little arrows in there. So DE is parallel to AC. And then the other cool thing is that DE is half the length of that side AC. Bless you. Or another way to think about it is that AC is twice as long as DE. Those say the same thing, they just look a little bit different. Alright, so we're going to use that this entire lesson about midsegments. Okay, so the first one, you'll notice that you have lots of lines along there so that they tell you that they are midpoints. So let's just go through. XY is a midsegment and it is parallel to what side? QS, yeah. The side that it doesn't intersect. So XY parallel to QS. Then we got this guy, WY. What side is it parallel to? Which one? QR. There we go. So WY parallel to QR. And the last midsegment of the triangle, XW, and which side? RS, yeah. The cool thing about parallel lines from last chapter is that you have like corresponding angles. So we don't talk about it a lot, but that's another cool thing about midsegments. Let's not do that one. Alright, so midsegments are parallel. They're also half as long as the side they are parallel to. So here it tells you that LMN are midpoints. All that tells you then is that all of these segments in between are midsegments. Okay, then it tells me PR is 46. So which line is the midsegment parallel to PR? LM. And it's half as long, so how big is LM? 23. Okay. Then it says PQ is 40. So what's the midsegment that's parallel to PQ? MN. And how big does that have to be? 20. And then it tells me LN, this guy, is 17. Well, what's parallel to it? QR. So is QR going to be half as big as 17? It's going to be twice as big. Yeah, this one you got to think opposite. So if I double 17, I get 34. Good. So this whole thing QR is 34. If I just want to find MR, remember M is a midpoint. How can I find MR? Half a QR, yeah, half a QR is 34, half of that is 17. You'll notice that that's the same as your mid-segment, so it's kind of like your mid-segment comes out and makes like 2 that get added together. Alright, here it says FGH are midpoints, so I have a bunch of mid-segments. If FG is 9, what side's parallel to it? DE, yep. So how long is DE? Yeah, 18. Then it says GH is 7. So which side's parallel to that? CE. So how big is CE? 14. Okay, then it tells me CD, now that's an entire side, CD, is 24. So what's parallel to that? FH. So how big is FH? 12. Good. And then it says, we need to find the perimeter of CDE. CE we said was 14. DE we said was 18. So the perimeter is just all the way around. So 24, 14, and 18 gives me a total of 56. Alright, questions so far with mid-segments? Okay, now of course we gotta throw some algebra in there. Okay, now here's, you remember in that first slide, I told you that taking half of something is the same as doubling the other thing? Well, if you take half of x, that kind of gets confusing. So that's why I like to double the mid-segment. It's still the same sort of thinking. If you want to take half, you will get the same thing. It's just that you might get a lot of decimals on the way. So if I look at this 7x, that's my mid-segment. I need to double that to get my side. Okay? So I need to take it times 2 to get this side. So I'm going to take 2 times that mid-segment, which is 7x, and that has to equal my side, 17x minus 18. The other way to set this up is to take half of that 17x minus 18 and set it equal to 7x. Either way is fine. I just don't like dealing with fractions. Alright, so 2 times 7 is 14. So 14x equals 17x minus 18. I'm going to subtract the 14x and then add the 18. And then you get x to be 6. Questions there? Okay, same thing here. I'm going to double the small line. So double the 6x plus 31, and it has to equal the big side of 19x minus 36. You guys remember how to distribute? Yeah. Okay. So 2 times 6, 12x plus 2 times 31, 62. Still equals that 19x minus 36. Subtract your 12x, we get 7x. Add your 36, we get 98. Which makes x 14. Of course. course, on a quiz test, I would recommend that you plug that back in. But I think you can trust me. I just hope you can.
Quiz test?
What?
You said quiz test?
On a quiz test, yeah. Like on a quiz or a test.
Oh, there's like a double whammy.
A quest.
Yeah.
Alright. Lesson 6 is all about medians and altitudes. Those are just two fancy terms for something that is kind of basic. A median goes from a vertex. A vertex is like an angle to a midpoint. And I know that it's a midpoint because it has the dashes. So it joins a vertex to a midpoint. And obviously it has to go to the other side. Otherwise it would just be like a weird half line of your side of your triangle. So this is your median. So when you're looking for medians, you gotta look for the dashes on either side of your dot. So it'll tell you it's a midpoint. Alright, where the three medians meet is called a centroid. I don't know why they didn't just call it the center. They just had to make it fancy, I guess. Anywho's. Alright, so here I have medians. If I look here, I have dashes, so that means D must be a midpoint. And then the vertex opposite it is C. So one median is CD. I also know that F is a midpoint because it's got the dashes here. And then the vertex opposite it is B. So we got BF. And what's the last median? E and A. EA Sports. Exactly what I was thinking. Alright, where those three meet is this point that I've covered up on your paper. B, B, B. Alright. We have some fancy things with medians and centroids. I'm going to erase this lovely drawing that I did. Mid-segments are half as long. Centroids, you got to break things down into thirds. Okay, so if I look at this median AE, I like to break it down into a box. And do you think P is halfway in between? No, it doesn't look like half. It's actually thirds. So this is how I show medians. AP is 2/3 the whole length, and PE is 1/3. So from A to P takes up 2 boxes. P to E is 1 box. Okay? So in terms of the whole line, AP is 2/3 of the whole line AE. And PE is only 1/3 of the whole line AE. And then you can also relate AP and PE. If I'm looking at AP in relation to PE, AP is twice as long as PE. And then you can write that the other way, that PE is half as long as AP. We don't use these two that much, but they are related. Alright, we're going to go over another term for line, then we're going to look more at centroids. We also have this thing called altitudes. Altitudes, the most important thing is that it has the box, the right angle. Okay? Anything that has a right angle and goes to the opposite side vertex is called an altitude. So it joins a vertex to the opposite side that is perpendicular to that side. Perpendicular, 90 degrees, box thing. The weird thing about altitudes is that they can be literally anywhere. They could be inside, like this, vertex to opposite side. They can be outside of your triangle. So if I look at this vertex, the only way to get to 90 degrees to this side is to go outside of my triangle. Or if you have a right triangle, they can actually be that side. That obviously only works if it's a right triangle. Here, if you have an acute triangle, it's going to be inside. And if you have an obtuse triangle, it's going to be outside. I don't ever really have you draw them. I just kind of have you name them like in this little diagram down here. Alright, where the three altitudes meet, altitudes, is called the orthocenter. I don't think I'll ever ask you about the orthocenter, but fun facts. I don't know why it's called orthocenter either. You could probably Google it. Alright, we're just going to list the altitudes. So if I look at vertex A, and then I see a 90-degree angle next to E, that would be my altitude, AE. If I look at my vertex B, and then I follow to make a right angle, BF. And what's the last one? CD. So an angle of your triangle over to a 90-degree angle. Alright, so combining the two, you gotta decide if it is a median altitude or neither. Give you a hint, if it's at a right angle, it's probably an altitude. It has dashes, like it's a midpoint, it's a median. What's the first one? What?
Or altitude.
Thanks.
My bad.
Altitude.
Stop.
It has the right angle, so it has to be an altitude. What's the middle one? A median. It's got this midpoint. I know it's a midpoint because it's got the dashes. This is a median. And the last one, does it have a right angle? No, so it can't be an altitude. Does it have dashes that shows a midpoint? No, so this is neither.
Oh, shoot.
Alright, triangle DEF is this huge, big triangle. Okay, DEF, I know there's lots of little small triangles, but it'll be okay. Alright, first off, find me a point that's a midpoint. L. And I know it's a midpoint because it's got the dashes. Okay, what's the vertex opposite L in the big triangle? D. So that means DL has to be a median of that triangle. Okay, altitude means right angle. Find me a right angle. K. And then the vertex opposite K is F. So that has to be an altitude. F, K, KF, whatever. Alright, here's where it gets a little tricky for me because we're looking inside this triangle, so it's all whack. Alright, E, H, F. E, H, F is that blue triangle. Median means midpoint. Find me a midpoint in there. L, same place. This time I'm not going to D. I'm going to H. H, L. Alright, then I got triangle, H-E-K. H-E-K. Altitude means right angle. Where's my right angle? At K, the one opposite it is what letter? H. It's a right triangle, so it's just that side. On a quiz test, I don't think I'd give you one that complicated because I don't like looking at the inside stuff. Alright, centroids. That's where we break it down into thirds. So it tells me DH, this whole line, is 51. So what I like to do is I like to draw my little box, D, H, and break it down into thirds. And then the J, which is bigger, DJ or JH? DJ is bigger, right? Looks bigger, right? So that means D to J has to be longer than J to H. Okay? I know the whole thing is 51. So how can I figure out what each box is? Divide by 3. What's 51 divided by 3? 17. So each box has to be 17.
Wait, where did you get the 3 boxes?
From here. It breaks down into thirds. So anytime you see centroid, you break it down into 3. Alright, so if each box is 17, how big is D to J? 34. And how big is it from J to H? 17. Okay, so we've used the DH one. I'll cross that off. GF is my whole line. So let's go ahead and draw our whole line. We got G, we got F, and we have a centroid. So I'm going to break it down into 3. And it says that that whole line GF is 60. Now you have to decide which one's bigger, GJ or JF. JF is bigger, so that means that JF gets the 2 boxes, since it's bigger. So this line kind of looks like this line. It's just broken up into thirds. If my whole line is 60, what's each box?
20.
20. So how big is GJ? 20. And how about JF? 40. Then we got EI, which is my whole line. So E to I. J is my centroid. So where should the J go? Here or here? The second one. Because EJ is longer than JI. The whole line, it says, is 57. So what's each box? 19. So how long is EJ? 38. And JI? 19. Okay, one more. V is my centroid, so V is where all of my medians meet. I have SR, my whole line. Should V go on the left or the right in between the SR?
Left.
On the left. Because SV is smaller, VR is bigger. Okay, it says the whole thing SR is 21. So each one is 7. Alright, so SV is, and VR is, nice. Okay, this time it says VU is 8. So we just have this, okay? We're going to write the whole line down though, because I want the whole thing in order to break it up into thirds. So I have Q, U. Is V going to go on the left or the right? On the right, because QV is bigger than VU. Now I know VU is 8. So that means each box in here has to be 8. So how big is QV? 16. And then QU, the whole line is 24. Nice. Then we got PT, the whole line is 15. Where's V going, left or right? All right. How big is each box? 5. So PV is, and VT is, nice. So your mid segment, when it's just the one line parallel to your side, is half centroid. Break it down.